Christchurch is surrounded by great natural beauty. Within the sights of the city, there are spectacular coastlines, mountains, rivers, lakes and estuaries, all making it a diverse and special place to live. Christchurch City, now home to over 375,000 people, was founded on swampy, low-lying land. As the city grew, it became more and more important to have responsible and sustainable drainage and wastewater treatment systems. Christchurch's wastewater was first pumped to a treatment site in Bromley on September 14, 1882. The present Christchurch wastewater treatment plant was built at the site in 1962. Over the years, water quality has been steadily improving thanks to upgraded treatment processes, and today 99.999% of all bacteria have been removed by the end of treatment. An average of 170 million litres of wastewater travels through the treatment plant every day from 150,000 homes and businesses in the wider Christchurch area. In wet weather, there is 3 times this amount. All wastewater is processed through the plant and oxidation ponds, and until recently was discharged into the Avon Heathcote Estuary, also known as Ihutai. In 2001, Christchurch City Council applied for consent to continue this discharge, but Environment Canterbury asked for an alternative, long-term solution. Wildlife advocates, local iwi, residents and recreational users of the estuary provided support as Christchurch City Council and Environment Canterbury began investigating alternative ways to dispose of the highly treated wastewater. After extensive consultation, the decision was made to construct a 3-kilometre-long ocean outfall to discharge directly out to sea. This would make it one of the longest and largest ocean outfalls ever built in Australasia. It would also be the most expensive project ever undertaken by the Christchurch City Council. The new pipeline would be 4.8 kilometres in overall length, 1.8 metres in diameter, and capable of transporting 6 cubic metres of water a second, enough to fill an Olympic swimming pool in only 7 minutes. To encourage the use of best construction technologies available, 2 radically different construction options were proposed for building the onshore section of this pipeline. The first involved the traditional dig and lay construction, where the pipeline would be laid in deep trenches. This is a proven and cost-effective method, but digging and maintaining trenches of that size would cause major disruption to the local residents and have a significant environmental impact. The second option was micro-tunnelling, where a specialised tunnel boring machine is used to construct the pipeline deep underground without disturbing anything on the surface. This technology is new in New Zealand for pipelines of this size. This method has far less impact on the environment. Because the pipe slopes continuously downwards, it would be mostly gravity operated, meaning electricity would only be needed occasionally to pump the wastewater, an outcome which only micro-tunnelling could achieve due to the depth of the pipeline. So the gravity-fed tunnelled pipeline would have significant long-term cost benefits. In 2006, New Zealand construction company McConnell Dowell Constructors submitted a competitive proposal using the micro-tunnelling method and were awarded the Ocean Outfall contract. URS provided complete engineering designs. A project of this size and complexity would require McConnell Dowell to import expertise, materials and equipment from the UK, Germany, Thailand and Australia, and also advise and support the local subcontractors and workforce that would carry out the construction works. The Ocean Outfall would be a 2.3 kilometre concrete pipeline from a newly built pumping station on the edge of the oxidation ponds, under the estuary, to a bend under South New Brighton Park, then along Jellicoe Street and under the dunes, beach and surf zone, to a point about 500 metres out to sea. From there, a marine pipeline would be laid in a trench excavated in the seabed, travelling a further 2.5 kilometres out to sea. Downer EDI Construction Works Infrastructure was awarded the contract to build the new pump station, and construction commenced on the Ocean Outfall Pipeline on November 15, 2006. The first stage of the pipeline project was to prepare the site in South New Brighton Park and construct the primary jacking shaft, a large hole 12 metres deep and 14 metres in diameter, where the tunnelling machine would begin work. The 55-ton tunnelling machine was manufactured by Heron Connect in Germany, especially for this project, and was officially named Dora the Borer by local schoolboy Roy Toner. To fit in with the surroundings, she was painted in Canterbury red and black stripes. Dora was craned into the shaft. She was then fitted into the specially constructed exit eye in the wall of the shaft and began her first journey, or drive, back under the estuary to another deep shaft near the pumping station. Dora was expected to travel, on average, 15 metres every day. As she travelled, 3-metre-long pipes would be lowered into the shaft and pushed in to extend the pipeline behind her. The reinforced concrete pipes were purpose-built in Thailand to withstand 800 tonnes of jacking force and shipped to New Zealand specifically for this project.
Each pipe was 7 tonnes, and we had, on this longest drive, we had almost 300 pipes, so that's more than 2,000 tonnes of pipe, but we managed to push it along with only using about 500 tonnes of the jacking capacity. We inject bentonite, which is a slippery clay lubricant. We pump that in through holes in the pipe, and this makes it slide along on a slippery, muddy bed of clay.
The sand and other material that Dora excavated to form the tunnel is mixed into a bentonite slurry, which is then pumped back along the tunnel to a separation plant in the park. Once separated, this material is transported off-site and reused. 2 days after tunnelling began, Dora encountered an unexpected obstacle: buried wood.
There's always challenges in tunnelling. It's very rare that you'll get a tunnel job that's the geology is always the same as you want it.
Wood is one of the worst materials a TBM like that can encounter. TBM cutting head's designed to cut through and excavate sand and stone. It's not really designed to cut through wood. It tends to chew it instead. This produces sort of slivers of timber that block the slurry lines. It's always a problem to deal with. The tunnellers will try different means of doing that. To clear a blockage to the slurry lines, they'll backflush them. They can reverse the cutting face and try and clear it that way. There's always a very high risk that if it's a significant piece of timber that is stopping the machine, you might have to get to the point where you need to dig the machine out and the wood with it and start again.
But the wood was flushed out. Dora kept moving, and on August 31st, 2007, she emerged at the pump station site right on schedule. The crew was surprised to see she still had her colours. Dora was then transported back to the jacking shaft site in the park to begin her next drive in the opposite direction, toward the sea. This drive was 10 to 12 metres below the middle of Jellicoe Street in the residential area of South New Brighton. It was therefore very important to ensure this did not create any settlement, which could cause problems for the road and nearby residences. For this reason, Dora had been fitted with an automated earth pressure balance system that supports the ground around the cutting head at all times. Dora began her second drive on the 15th of October. Everything went to plan, and 1 month later Dora emerged at the sand dunes. There was no sign that a 600-metre-long pipeline had just been laid under a residential street.
The tunnelling process was a very good one. There was really limited impact on us as residents, and some people weren't even aware that it was going on as it was going on.
Construction of the pump station continued, and by late 2007 it was nearly ready to house its 3 giant 375 kilowatt pumps. Preparations to construct the marine section of the Outfall Pipeline were also well underway. Christchurch company PPS Frank used technology new to New Zealand to manufacture the required 1.8 metre diameter high-density polyethylene or HDPE pipes. Each 6 metre length of pipe took 8 hours to form. They were then welded together into several long pipe strings at the assembly site in Littleton. Each pipe string was then pressure tested and had 15-ton concrete weights attached before being launched into the sea. The pipe strings were towed across to Diamond Harbour, anchored, and then sunk to the sea floor for safe storage. After successfully travelling under Jellicoe Street, Dora began her 3rd drive under the sand dunes and beach and out under the ocean. On this final drive, Dora travelled an incredible average of 26 metres a day. By the start of 2008, McConnell Dowell had laid the 2.3 kilometre long tunnelled pipeline within 9 months. The first stage of construction was a success. Dora remained under the seabed until the marine pipeline was ready to be connected to the tunnel pipeline. In the following few months, the pipelines were connected in the shafts, in the park and dunes, and then the shafts were backfilled. The sites were then cleared and restored to their original condition. Jellicoe Street also received a facelift, including buried power lines, intersection improvement, and new street landscaping. The final and most challenging stage of the Ocean Outfall project, the installation of the marine pipeline, began in November 2007. McConnell Dowell subcontracted the seabed excavation work to New Zealand dredging company Heron Construction. Their large dredging barge, Machiavelli, was towed to the outfall site in Pegasus Bay. The barge has retractable legs which hold it in position, while the 230-ton GPS-controlled backhoe excavator digs up to 20 metres below it. But there are limits to dredging in the open sea. The Machiavelli typically had to stop work when waves became bigger than 1.5 metres. Extended bad weather meant no work could be done at all for long periods, while wave action was refilling trenches that had already been dug.
The winter of 2008 was particularly bad for sea conditions. In a storm at the end of July, we recorded on site waves exceeding 9.5 metres. These you'd expect only once every 15 to 20 years.
In February 2008, the first of 7 pipe strings was prepared for laying in Pegasus Bay. With the concrete weights fitted, each string weighed 1,300 tonnes. But when filled with air, the string floated, enabling it to be towed 12 nautical miles out to the site. The string was then carefully filled with water and progressively sunk into the 4-metre trench in the sea floor. To avoid damage to the HDPE pipe, it was critical that it was not allowed to bend too much as it sunk. The pipe strings had to be held as straight as possible by applying up to 50 tonnes of tension. It was a complicated operation involving several vessels, using lots of equipment and divers, but the first pipe string was eventually laid successfully on the 17th of February 2008. In March 2008, the second pipe string was sunk into place, and a team of specialist divers from Bay Underwater Services connected the strings together. The divers worked largely by feel and near zero visibility and under direction from engineers on the barge. In depths of up to 21 metres, it was a painstaking process requiring thorough preparation. Over the next 12 months, 4 more pipe strings were floated out to sea and successfully connected. In April 2009, the last and most important pipe string was installed. 13 diffuser structures were fitted to the end of the Outfall Pipeline, each with 8 duckbill valves, 104 in all. The valves maximise the dispersion and ensure that the treated wastewater is released into the sea environment unnoticeably. The last construction job was to dig out Dora and return her back to dry land. Submersible buoyancy tanks were attached and used to float her to the surface and tow her back to Littleton. A short section of HDPE pipe was then installed in her place to connect the micro-tunnel to the marine pipeline and allow the whole pipeline to finally be tested and commissioned. By the time the last work was finished on the marine pipeline, restoration was nearly finished at the construction sites on land, leaving very little evidence that a major project had happened at all. The Ocean Outfall passed its most important test when trials confirmed that it was safely discharging the treated wastewater and meeting the dispersion requirements. It took just over 3 years, but the largest project ever undertaken by the council had been successfully completed. Mayor Bob Parker pressed the start button on the newly completed pumping station at a grand opening in March 2010. And now that wastewater isn't being discharged into the estuary,
scientists say that within 5 years we'll see a major difference. And I think it has tourism potential. And a number of people around the area have recognised that there is tourism potential in the estuary.
the Christchurch Ocean Outfall Pipeline is a huge success for Christchurch residents. It's an innovative project, and most of the work was completed by local contractors and workers with minimal environmental impact. This pipeline's completion also coincided with a large upgrade to the wastewater treatment plant, meaning the wastewater is even cleaner. Constructing the Ocean Outfall is a remarkable achievement, which the Christchurch City Council and McConnell Dowell are both very proud of. The pipeline will serve the city's residents for many years to come.